This is the video for homework 7, question 8. A Poisson process is defined by the following properties. The number n t1 t2 of the points ti in the interval t1 t2 of length t is a Poisson random variable with parameter lambda t, this expression. And if the intervals t1 t2 and t3 t4 are non-overlapping, then the random variables n t1 t2 and n t3 t4 are independent. And property number 3. At a time moment t, there is no more than one Poisson point. Using the points ti, we can form the stochastic process xt equals n0t. That is one demonstration of the xt. Now we have to find expectation and the E and R. To find expectation, we have to we can refer back to the general Poisson variable. Pex equals k is e to the power of minus lambda multiplies lambda over to the power of k divided by k's factorial. We have that the sum of it for all k's from 0 to infinity should add up to 1. That is this expression. And then we can take derivative on both sides of the equation and we get that k, sum of k to the from 0 to infinity, k times lambda to the power of k minus 1 over factorial of k equals e to the power of lambda. And in this way, we can find that the expectation of x, this random variable x, is lambda. And then we can find the sigma squared. That is, by definition, expectation of x squared minus expectation of x to the power of 2. That is this expression. And we have to find the expectation of x squared. To find this, we can take the derivative again of on both sides of this equation, and we get that the sum of k squared and this times this is minus plus 1 times e to the power of lambda. I'm sorry, lambda plus 1 times e to the power of lambda. And then we can multiply lambda on both sides, and then we get that expectation of x squared is the expression. We take the e to the power of lambda back to the left side, and we get this. We can also find the the sigma squared to be lambda. This sigma squared is the sigma squared of this variable, the variance of this variable. And therefore, we can substitute lambda in this expression with lambda t to get that of expectation and the e and sigma squared for xt. That is, ext is lambda times t, and variance of xt is also a function of t, is also lambda t. And for the B part of the question, we have to find R. And we can divide it into two parts because this involves the relationships between T1 and T2. If T2 is larger than T1, then we know that xt1 minus x0 and xt2 minus xt1 are independent. That is given in the problem. And R, by definition, is this. And we can break it down. We can break down xt2 into xt2 minus xt1 plus xt1. That is equal. That is equivalent. And we can break it down to these parts. Expectation of xt1 times expectation of xt2 minus xt1 plus the expectation of xt1 to the power of 2. And then we get lambda t1 times lambda t2 minus lambda t1 plus lambda t1 times lambda t1 plus 1. And these parts are cancelled. These two are cancelled. So we get lambda squared t1 t2 plus lambda t1. And similarly for t1, for that t1 is larger than t2, that is symmetrical. We get that r t1 t2 is lambda squared t1 t2 plus lambda times t2, different from here. So we get that overall r is lambda times minimum of t1 t2, that is the smaller one of t1 and t2, plus lambda squared times t1 t2.